The angular position of a rod varies as 20 t² radians from time t equal to 0. The rod has two beads as is shown in the following figure. So this bead is at 10 centimeters and that bead is at 20 centimeters from the rotation axis. What is the instantaneous angular velocity of the rod at t equal to 5 seconds? Okay, so angular position is given as 20 t² and angular velocity. So angular velocity as a function of time is d theta by dt, and that's equal to, so derivative of this would be d by dt of 20t² is equal to 40t. And they want us to find the angular velocity at t equal to 5 seconds. 40 times 5 equal to 200 radians per second. What is the angular acceleration of the rod? B alpha is d omega by dt equal to d by dt of 40t equal to 40 radians per second squared. What is the tangential speed of the bead at t equal to 5 beads at 5 seconds? So part C, the tangential speeds are omega, and so alright, let's add a page below. So for the bead at 10 centimeters r equal to 0.1 meter, the tangential speed is we'll go r omega, which is 0.1 meters times at t equal to 5 seconds, it's omega is 200 radians per second. So this will work out 20 meters per second. And for r equal to, for the bead at 20 centimeters, which is 0.2 meters, the tangential speed is 0.2 meters times 200 radians per second, which is 40 meters per second. Okay, and then what are the tangential accelerations of the bead at t equal to 5 seconds? Okay, so the tangential acceleration is r alpha. So for r equal to 0.1 meters, tangential acceleration is 0.1 meters times alpha is 40 radians per second square. So this is 4 meters per second square. And the tangential acceleration for r equal to 0.2 meters is 0.2 meters times 40 radians per second square, and this is 8 meters per second square. And the last part is they want us to calculate what are the centripetal accelerations of the bead. So the centripetal accelerations, so bead going about that axis, the centripetal acceleration is v square by r equal to r omega square by r omega square. Okay, so for r equal to 0.1 meters, and we're finding all this at t equal to 5 seconds. t equal to 5 seconds. The centripetal acceleration is 0.1 meters, and omega is, at 5 seconds, omega is 200 radians per second. So this is 4,000 meters per second. Wow, that's quite a large centripetal acceleration. And for r equal to 0.2 meters, the centripetal acceleration is, again, r omega squared. Let me make sure that omega is indeed yep, okay, 0.2 meters times 200 radians per second square, and this works out to 8,000 meters per second square. Alright, these are fairly large accelerations. Okay, that finishes the problem.